Hey, hi everyone. A very good morning to all of you. Am I audible and visible properly? Let me just check it. Okay, so everything fine. Let's continue with our session. So in the last lecture, we discussed order and degree of a partial differential equation. Then we discussed the difference between linear and non-linear partial differential equation. Then we discussed the type of equations which are first order, and then how can we classify them as linear, as semi-linear, as quasi-linear, and as non-linear. So non-linear has higher power of p and q. Order one ही रहेगा. I mean to say in the equation there will be p and q only, but the power will be more than one in a non-linear partial differential equation. Quasi-linear में p और q वन पावर में रहेगा, बाकी जगह x y z की पावर कैन बी एनी पावर ऑफ एक्स वाई एंड जेड. सो ये नॉन लीनियर एंड क्वाजाई लीनियर का डिफरेंस हमने समझा. हमारा जो नेक्स्ट टॉपिक है दैट इज फॉर्मेशन ऑफ पार्शियल डिफरेंशियल इक्वेशंस. हाउ कैन वी फॉर्म द पार्शियल डिफरेंशियल इक्वेशन फॉर द गिवन सरफेस. किस तरह से हम पार्शियल डिफरेंशियल इक्वेशन को फॉर्म कर सकते हैं. सी इसमें आपके पास देयर विल बी थ्री मेथड्स. फर्स्ट विल बी बाय एलिमिनेटिंग द कॉन्स्टेंट्स, बाय eliminating constants. The second method will be by eliminating function, है ना. और थर्ड मेथड भी सेकेंड के सिमिलर ही रहेगा, but there will be more than one functions in it. So by eliminating functions. So these three methods are there in the formation of a partial differential equation. Let's discuss the rule number 1. बाई एलिमिनेटिंग कॉन्स्टेंट्स. अब ना कॉन्स्टेंट्स दो तरह की होती है. वन इज़ द फिक्स्ड कॉन्स्टेंट, द अदर वन इज़ द आर्बिट्ररी कॉन्स्टेंट, है ना. जैसे फॉर इंस्टांस एक्स स्क्वायर प्लस वाई स्क्वायर इज इक्वल टू 1 एंड एक्स स्क्वायर प्लस वाई स्क्वायर इज इक्वल टू सी. So it is a circle of radius 1, but it is a circle of radius c. So c here is a constant which can vary. C can take any value. This is known as an arbitrary constant. ये c जो है ये कुछ भी वैल्यू, कोई भी रियल नंबर हो सकता है. सो जब हम पार्शियल डिफरेंशियल इक्वेशन को फॉर्म करेंगे वी विल एलिमिनेट दिस आर्बिट्ररी कांस्टेंट. ठीक है. अगर एग्जामिनर इन द क्वेश्चन इफ इट इज मेंशन्ड दैट c is an arbitrary constant, you have to treat c as arbitrary constant. But for instance x square plus y square plus 2hx plus 2gy is equal to z. Let's suppose this is the equation. Here I can see that there are two constants h and g. So if it is not mentioned in the question, h and g both are arbitrary, दोनों arbitrary है. बट मान लो कई बार वो मेंशन भी कर देता है कि g इज़ एन आर्बिट्ररी कांस्टेंट. सो h आपको फिक्स्ड ट्रीट करना है उस केस में. यू कान ट्रीट h एज आर्बिट्ररी कांस्टेंट. तो इसका मतलब हमें h को एलिमिनेट नहीं करना पड़ेगा उस केस में. ठीक है. सो जो आर्बिट्ररी कांस्टेंट मेंशन्ड है आपको उसी को एलिमिनेट करना होता है. और अगर कोई सा भी कांस्टेंट आर्बिट्ररी मेंशन्ड नहीं है देन ऑल द कांस्टेंट्स नीड टू बी एलिमिनेटेड from the equation. Now how will you eliminate the constants? By differentiating the given partial differential equation. By differentiating कैसे? Obviously you have to treat a variable as dependent variable. So normally z जो है वो dependent variable रहेगा. So you will differentiate with respect to x first. With respect to x differentiate करो, then differentiate with respect to y. I mean to say you will get an equation in del z by del x form. You will get an equation in del z by del y form. If needed, you can differentiate further as well. You can differentiate second time del square z by del x square, del square z by del y square. You can differentiate del square z by del x del y. Right. So when you will be differentiating the given surface ना, each equation will be treated as a new equation. So in total आपके पास जितनी भी equations आती हैं, with the help of them, if you are able to eliminate the constants, so बस then eliminate the constants, you will get an equation. आपको basically you have to find a partial differential equation in which there will be no constant. So आपको constants को eliminate करना होता है. Let's understand this by an example. जैसे ये example हमें given है. ये example है जैसे z is equal to ax plus by a square plus b square. You have to eliminate a and b. We have to eliminate a and b. So जैसा मैंने बताया, you first of all differentiate it with respect to x. Differentiate with respect to x. Let's suppose this is our equation number 1. So del z by del x is equal to a plus c. b into y means 0. When I'm differentiating with respect to x, y remain constant here. Y remains constant here. Right. So derivative of by with respect to x 0. Derivative of a square plus b square with respect to x 0 again. So I got a is equal to del z by del x from here. I'll name it as equation number 2. Now you find del z by del y and that is equal to b. Okay, now this is equation number 3. Now look at equation 1, equation 2 and equation 3. Can you eliminate a and b? मतलब can you make an equation in which there is no a and b? Using all these 3 equations, इन तीनों को यूज़ करके obviously मुझे यहाँ से a मिल रहा है, मुझे यहाँ से b मिल रहा है, मैं फर्स्ट में पुट कर दूँगी. Getting me? So you don't need to differentiate again. You got a, you got b, you put it in the first equation. So put a and b in equation 1. Equation 1. So we get z is equal to del z by del x into x plus del z by del y into y plus del z by del x whole square plus del z by del y whole square. Del z by del y whole square. And this is your final equation. Because it is free from a and b, so this is the required partial differential equation. Required partial differential equation. ये अपना आंसर है. Understood? Now let's move to the next question. Let's move to the next question. जैसे ये question है, इसमें इसने mention किया हुआ है that p and a are both are arbitrary constants. Arbitrary constants. So we have to eliminate p and a, है ना? Now what about t here? t में तो confuse नहीं हो रही हो ना आप? आपको पता है किसी भी partial differential equation में एक वेरिएबल तो डिपेंडेंट रहेगा एंड जो रिमेनिंग वेरिएबल्स है वो इंडिपेंडेंट रहेंगे. सो इंस्टेड ऑफ y वी हैव t हियर. सिंपल सी बात है, x and t आर द अदर 2 वेरिएबल्स हियर. सो x and t आर द इंडिपेंडेंट वेरिएबल्स. सो जैसे हर क्वेश्चन में आई यूज टू फाइंड del z बाई del x, del z बाई del y. सो यहाँ पर यू हैव टू फाइंड del z बाई del x, del z by del t. Understood? So you differentiate first with respect to x. Differentiate with respect to x. I'll get del z by del x is equal to a e to the power pt cos px into p. Let's name it as equation number 1. Now del z by del t. I told you when I'll be differentiating with respect to t, x will remain constant. है ना? तो a sin px as constant and derivative of e to the power pt is p e to the power pt. Let's name it as equation number. Let's name it as equation number 2. Now you assess. See, equation number 1 अपना जो original equation है वो होता है. Then this is equation number 2 and this is equation number 3. Now you assess. Can you eliminate a and p using 1, 2 and 3? With the help of 1, 2 and 3, can you eliminate p and a? सी यू हैव टू गिव इट ए थॉट, ऐसे तो नहीं होगा, है ना. यू हैव टू गिव इट ए थॉट कि व्हाट changes, how can I combine these three equations so that there is no p and a in our equation, है ना. अगर आपको if you are able to combine them without the help of equation 1, that is also fine. If you are able to combine 2 and 3 only and you can eliminate p and a, even that is fine. तो आपके दिमाग में एक चीज़ तो आ रहा होगा, cos स्क्वायर थीटा प्लस साइन स्क्वायर थीटा 1 होता है, तो वो करके देख लेते हैं. cos स्क्वायर पी एक्स प्लस साइन स्क्वायर पी एक्स इज इक्वल टू 1. फ्रॉम हियर आई एम गेटिंग cos पी एक्स. cos पी एक्स क्या आएगा, 1 बाई ए ई टू द पावर पी टी इंटू पी, बट नो नहीं होगा उससे एलिमिनेट, बिकॉज cos पी एक्स इज 1 बाई ए ई टू द पावर पी टी इंटू पी del z बाई del x होल स्क्वायर, एंड यू कैन नॉट एलिमिनेट दिस नाउ. ये रहेगा इक्वेशन में. सो दिस इज नॉट हाउ वी कंबाइन इट. इसको नहीं कंबाइन किया जा सकता है. we cannot get a partial differential equation from here because I can't combine 1, 2 and 3 in order to eliminate p and a. p and a still rahega. Now what you can do is you differentiate again del square z by del x square, and that is equal to a to the power pt minus p sin px, and this can be written as minus p square a to the power pt sin px, and del square z by del t square, del square z by del t square del square z by del t square is equal to del square z by del t square is equal to basically a sin px into p square e to the power pt, and this is equal to a p square sin px e to the power pt. Now you see how can we eliminate. Now you see how can we combine. Let's say this is equation number 4 and this is equation number 5. Now you tell me how can we eliminate p and a. A p squared sin px e to the power pt as del squared z by del t square. If you observe, then del squared z by del x square plus del squared z by del t square is equal to 0. है ना. So this is a partial differential equation in which there is no p and a. There is no constant in it, है ना. कोई constant इसमें नहीं है. So we got our equation and this is your final answer. This is our final answer. Now the question, you may have the question कि we didn't use 1, 2 and 3. 1, 2 and 3 नहीं required था. I told you, you keep getting equations. आपके पास 1, 2, 3, 4, 5, you keep getting equations and you have to adjust any 2, any 3. You have to get a partial differential equation by eliminating the constants, by eliminating arbitrary constants. So हमें ज़रूरत नहीं है 1, 2, 3 की. I can combine 4 and 5 and I got an equation which was free from arbitrary constants. So this is our required equation. ये हमारा आंसर है. Now एक question आपके दिमाग में ये आ सकता है, can we have multiple answers? Yes, in partial differential equation you can have multiple answers, but generally when there are two constants you will get a unique answer because सबका ना सेम ही सिनारियो रहेगा, है ना. Like I can't combine 1, 2 and 3, तो those cannot be combined. Only 4, 5 can be combined in order to free p and a, in order to eliminate p and a. तो कोई दो का different answer क्यों आएगा. But yeah, if there are one constant, if there is one constant, or if there is more than two constants, then answer can vary. तो multiple answers भी आ सकते हैं, उस केस में multiple answers आ सकते हैं. All good. Now let's move on to the next question. ये question आप homework के लिए रखो because this is very similar to our last question, है ना. This is very similar to our last question. Let me tell you the answer here. Del square z by del x square is equal to del z by del t. You tell me, did you get the answer or not? ये आपका आंसर रहेगा. Next question. Z is equal to ax cube plus by cube. A and b are arbitrary constants here. So यहाँ से first of all you differentiate with respect to x. Differentiate with respect to x. So del z by del x is equal to 3a x square and by cube का डेरिवेटिव तो ज़ीरो रहेगा. del z by del y is equal to 3by square. Let's name it as equation number 1. Let's name it as equation number 2. Let's name it as equation number 3. Now can you combine 1, 2 and 3 in order to eliminate a and b? Obviously I can combine. यहाँ से I get a. I'll get a as equal to 1 by x square del z by del x, and from the third equation I'll get b as equal to 1 by 3y square. Sorry, यहाँ पर 3 भी आएगा. 3y square del z by del y. Now you put a and b in the very first equation. बस. So z is equal to 1 by 3x square del z by del x. This is our a into x cube plus 1 by 3y square into del z by del y into y cube. So this is equal to x by 3 del z by del x plus y by 3 del z by del y by 3 del z by del y, and this is your required partial differential equation. You can adjust it so that it looks nicer. So del z by del x plus y del z by del y is equal to 3z, and this is your final answer. Now for the next question. Let's say this is equation number 1. Again a and b needs to be eliminated. See, whenever he does not mention a and b needs to be eliminated, what will you do? You will basically eliminate whatever constant you see in the equation. Constant तो समझ आता है ना आपको. x, y, z are variables. Constant आपका normal a, b, c, lambda, mu, all these will be the constants here. So you first differentiate with respect to x. Differentiate with respect to x. So ये आ जाएगा 4 del z by del x is equal to twice ax plus y by a plus y by a plus b into a. So it implies we have del z by del x as equal to 1 by 2a ax plus y by a plus b plus y by a plus b. We name it as equation number 2. We name it as equation number 2. Now for differentiate with respect to y. Differentiate 1 with respect to y. With respect to y. So 4 into del z by del y is equal to 2 ax plus y by b, y by a plus b into 1 by a, into 1 by a. So del z by del y is equal to 1 by 2a bracket ax plus y by a plus b, y by a plus b. Let's name it as equation number 3. Now can you eliminate a and b using 1, 2 and 3? Can you combine 1, 2 and 3? तो अगर आप if you carefully observe, then ax plus y by a plus b is here. यहाँ से I can take out the value of ax plus y by a plus b whole square is equal to 4z है मेरे पास. अब यहाँ पर भी है same expression ax plus y by a plus b. Same expression is here as well, ax plus y by a plus b. So definitely if I multiply these two, I'll get whole square ना. If I multiply 2 and 3, अगर आप 2 और 3 को multiply करो, so 2 into 3 implies del z by del x into del z by del y is equal to 1 by 4 a into 1 by a and ax plus y by a plus b whole square, y by a plus b whole square. A से a got cancelled out and this is equal to 1 by 4 into, now what is ax plus y by a plus b whole square? It's 4z. So 1 by 4 into 4z, right? And the answer here is equal to z. So del z by del x into del z by del y is equal to z, right? And this is your required partial differential equation because in this there is no constant, कोई a और b यहाँ पर नहीं है. Now coming to the next question. Now here we have three constants. यहाँ पर अपने पास तीन constants हैं. So we have to eliminate three constants a, b and c here. So solution. अपना procedure same रहेगा. Let's name it as equation number 1. Now differentiate with respect to x. Differentiate with respect to x. So del z by del x is equal to 2ax plus by and differentiation of cy square with respect to x will be 0. So let's name it as equation number 2. Now differentiate with respect to y. With respect to y. Right. So del z by del y is equal to bx plus 2cy. 2cy. Let's name it as equation number 3. Now you see, can we combine 1, 2 and 3? Because we have three constants here. So even if I'm able to get b using 2 and 3, b मिल जाएगा मुझे, but a और c तो नहीं मिलेगा ना. So if you have more than two constants, now you definitely have to find higher order derivatives because there are more than two constants है ना. So यहाँ से del square z by del x square निकाल के रख लो. Del x square is equal to 2a and del square z by del y square is equal to 2c. Is equal to 2c. Now I need b as well. So you differentiate del square z by del x del y as well. Differentiate it with respect to y or differentiate it with respect to x. है ना. तो when I'll be differentiating it with respect to y, तो I'll get b here. ठीक है. देखो ये zx है, इसको I can differentiate with respect to x again and with respect to y as well again because I have two variables x and y, different variables हैं, है ना. तो ये पार्शियल डिफरेंशिएशन में इट कैन बी देयर. सो यहाँ से मुझे a मिल गया, यहाँ से मुझे b मिल गया, यहाँ से मुझे c मिल गया. I'll insert a b c in equation number 1 and I'll get a equation which is free from a b c. So यहाँ से a आ जाएगा 1 by 2 z x x and यहाँ से c is equal to 1 by 2 z y y and from here b is equal to z x y. So put all these, put a b c in 1. Put a comma b comma c in equation number 1. So I'll have z is equal to ax squared, that means 1 by 2 zxx x square plus bxy, that is zxy into xy plus cy squared, that is 1 by 2 zyy into y square. And this is an equation which is free from ABC and this will be your required partial differential equation. ठीक है. Now moving on to the next question. अब जैसे this is the question, here we just have two variables, दो ही variables हैं यहाँ पर. So let's discuss it. Can we eliminate a and b? How can we eliminate a and b? You can also try it on your own. So solution. So you have to first, let's name it as equation number 1. Now differentiate it with respect to x. Differentiate it with respect to x. We will have 2z del z by del x is equal to 3ax square. Let's name it as equation number 2. Similarly, differentiate with respect to y. Differentiate with respect to y. We will have 2z del z by del y is equal to 3by square. Let's name it as equation number 3. अब यहाँ से देखो, can we eliminate a and b? Obviously we can eliminate a and b. ये तो बहुत simple था. So from here I'll get a as equal to 2z by 3x square del z by del x, and from here I'll get b as equal to 2z by 3y square del z by del y. So you insert A and B in equation number 1. Insert A comma B in equation number 1 and you will get an equation. So solve कर लेना. Let me write down the answer here. 6x cube y square del z by del x plus 6x square y cube del z by del y plus 4z del z by del x into del z by del y is equal to 9x square y square z. 9x square y square z, and this will be the required partial differential equation. So you will reach till here. कर लोगे ना? तो इतना तो आपको खुद को करना पड़ेगा. ओके, तो नेक्स्ट टाइप पर मूव करते हैं. फॉर्मेशन ऑफ पार्शियल डिफरेंशियल इक्वेशंस बाय एलिमिनेटिंग आर्बिट्रेरी फंक्शन. अब क्या रहेगा ना, यू विल बी गिवन एन आर्बिट्रेरी फंक्शन. जिस तरह से आई टोल्ड यू द डिफरेंस बिटवीन आर्बिट्रेरी एंड फिक्स्ड फंक्शन, उसी तरह से हमारे पास आर्बिट्रेरी फंक्शंस होते हैं. जैसे मान लो, एक तो मैं आपसे बोलूँ x प्लस वाई प्लस जेड इज़ ए फंक्शन इन x कोमा वाई कोमा जेड, है ना. और एक मैं आपसे बोलूँ कि देयर इज़ ए फंक्शन ऑफ x प्लस वाई प्लस जेड इज़ इक्वल टू 0. व्हाट इज़ द डिफरेंस बिटवीन दीज टू? यहाँ पर क्या है ना, इट्स पावर इज़ 1. This is the unique function in x plus y plus z. F is just this, but here there are many possibilities. जैसे if I write x plus y plus z whole square, ये भी इससे belong करेगा because it is a function of x plus y plus z. If I write x plus y plus z plus some constant 2, this is also a function of x plus y plus z, right? So ये भी यहाँ belong करेगा. So this is the difference between these two. Here we have a fixed function. But if I say that there is a function of x plus y plus z is equal to 0, it means it can be any function. ये कोई भी function हो सकता है x plus y plus z का. Understood the difference between the fixed function and arbitrary function? So यहाँ पर मान लेते हैं कि phi एक arbitrary function है u और v का. Again I told you it can be any function in u and v. And we have to eliminate phi here. हमें यहाँ पर phi को eliminate करना होता है. तो क्या करोगे? You will differentiate this relation with respect to x, just like we used to do in the first part. पहले आप क्या करोगे? Differentiate करो इसको with respect to x, and फिर differentiate कर दो with respect to y. फिर आपके पास ना एक del phi by del u बाई डेल फाई बाई डेल यू का डेल वी का एक्सप्रेशन आ जाएगा दोनों में, एंड दैट एक्सप्रेशन कैन बी इक्वेटेड. ठीक है, हम एग्जाम्पल के थ्रू समझेंगे, बट उससे पहले लेट मी टेल यू द चेन रूल ऑफ डिफरेंशिएशन. जैसे फाई अगर यू और वी का फंक्शन है, फाई इज़ ए फंक्शन ऑफ यू और वी, यू एंड वी. फाई एक्स और वाई का फंक्शन नहीं है. फर्स्ट ऑफ ऑल, यू एंड वी आर फंक्शंस ऑफ एक्स वाई जेड. यू इज़ ए फंक्शन ऑफ एक्स वाई जेड, v is a function of x, y, z. So when you will be differentiating with respect to x, जब आप x के रिस्पेक्ट में डिफ्रेंशिएट करोगे तो आप डायरेक्टली डेल फाई बाई डेल एक्स नहीं कर सकते हो. रीज़न बीइंग बिकॉज फाई इज़ नॉट ए फंक्शन ऑफ एक्स. फाई इज़ ए फंक्शन ऑफ यू, यू इज़ ए फंक्शन ऑफ एक्स. Similarly, phi is a function of v as well, and v is a function of x. Understood? Phi is in u and v. So phi can be differentiated with respect to u and with respect to v. ठीक है, and u and v can be differentiated with respect to x, y, z. ठीक है, तो जब आप phi को with respect to x differentiate करना चाहोगे तो phi पहले u में जाएगा, then u will be differentiated with respect to x, phi will go to v and v will go to x. So it will be both ways. Similarly, when you will be differentiating phi with respect to y, phi cannot go directly to y. ठीक है, so phi यहाँ पर v में जाएगा, v with respect to x में जाएगा, phi u में जाएगा, u with respect to, I'm sorry, I'm differentiating with respect to y ना. I have to differentiate phi with respect to y. So phi will go to v first and v will go to with respect to y, plus phi with respect to u and u with respect to y. Understood? And यहाँ पर you have to remember that z is the dependent variable. Z is a function of x and y both. You have to remember this thing as well. X and y are free, but z is a function of x and y both. एग्जाम्पल से समझते हैं ना। जैसे फॉर इंस्टांस ये फर्स्ट क्वेश्चन है, इसको करते हैं एक सोल्यूशन ऑफ क्वेश्चन नंबर 1। फॉर्म ए पार्शियल डिफरेंशियल इक्वेशन बाय एलिमिनेटिंग फाई फ्रॉम दिस इक्वेशन। फाई एक्स बाई वाई कोमा वाई बाई जेड इज इक्वल टू 0। सो यहाँ पर यू विल फर्स्ट राइट दैट u इज इक्वल टू एक्स बाई वाई एंड v इज इक्वल टू वाई बाई जेड। ठीक है, फाई हमारा u और v का फंक्शन है, is the given function is given to us. So basically phi is a function of u and v. U is further function of x, y, z. V is further function of x, y, z. Understood? So now first you have to differentiate with respect to x. Differentiate phi with respect to x. So phi of x will be equal to phi with respect to u with respect to x plus phi with respect to v with respect to x. Phi cannot be directly differentiated with respect to x, नहीं हो सकता है ये. Phi will be differentiated with respect to u, then u with respect to x. Phi will be differentiated with respect to v with respect to x होगा. Understood? तो this is equal to phi u as it is because we don't know phi u क्या है. phi u को आप as it is रखोगे, है ना. Now what is u with respect to x? अब u आपके पास है, you find u with respect to x. Derivative of u with respect to x will be 1 by y. Simple. So ये आ गया 1 by y plus phi v. Now v with respect to x. अब आपको लगेगा कि v में तो कोई x है ही नहीं, बट z इज ऑल्सो ए फंक्शन ऑफ x ना, ये आपको याद रखना है. z इज द डिपेंडेंट वेरिएबल. जब आप पार्शियल डिफरेंशियल इक्वेशन फॉर्म करोगे तो एक फंक्शन तो ऐसा रहेगा ना, एक वेरिएबल जो कि डिपेंडेंट रहेगा, राइट. सो z हैज़ टू बी ए डिपेंडेंट वेरिएबल. सो z इज ए फंक्शन ऑफ x. सो व्हेन आई विल बी फाइंडिंग v with respect to x, I have to write y into derivative of 1 by z with respect to x will be minus 1 by z square del z by del x. So I'll have vx as minus y by z square del z by del x. Del z by del x. ठीक है. Now phi is just equal to 0. So what will phi x be? Obviously 0. Phi with respect to u and v is given as 0. So phi with respect to x is equal to 0 only. So हमारे जो left hand side है, it will become 0. So it implies 0 is equal to phi u into 1 by y plus phi v into minus y by z square into del z by del x. From here you find the ratio of phi u and phi v. That means minus phi u by y is equal to minus phi v into y by z square del z by del x, del z by del x. And minus से minus got cancelled out. So from here I got the ratio of phi u and phi v, and this is equal to y square by z square del z by del x. We'll name it as equation number 1. Equation number 1. Now again differentiate phi with respect to y. Differentiate phi with respect to y. We have phi uv is equal to 0. So it implies phi with respect to y is equal to 0, है ना. But phi y क्या होगा? Phi is a function of u with respect to y plus phi is also a function of v with respect to y is equal to 0. अब u अपना था x by y and v was equal to y by z. V was equal to y by z. So this is it implies phi u as it is and u with respect to y क्या रहेगा? Differentiated with respect to y तो minus x by y square. v with respect to y क्या रहेगा? देखो यहाँ पर y is a function of y, z is also a function of y. So you have to differentiate carefully. तो y 1 by z as it is, derivative of y with respect to y is 1, so into 1 plus now y as it is, derivative of 1 by z माइनस 1 बाई जेड स्क्वायर विद रिस्पेक्ट टू वाई डेल जेड बाई डेल वाई। अंडरस्टूड? यहाँ पर 1 बाई जेड का डेरिवेटिव विद रिस्पेक्ट टू वाई क्या होगा? माइनस 1 बाई जेड स्क्वायर del z by del y. Always remember it because z is a function of y. Z is a function of x and y both, है ना? del by del y. So now place here uy और vy को place करेंगे माइनस एक्स बाई वाई स्क्वायर प्लस 5v इंटू वी वाई 1 बाई जेड माइनस वाई बाई जेड स्क्वायर डेल जेड बाई डेल वाई del z by del y. So from here it implies, and this is equal to 0. So here also I'll get the ratio of phi u and phi v. So phi u into x by y square is equal to phi v into 1 by z minus y by z square del z by del y. So here as well get the ratio of phi u and phi v. Let's name it as equation number 2. Let's name it as equation number 2. So as you can see, equation number 1 may be to the left hand side we have phi u by phi v, and in the equation number 2 as well to the left side we have phi u by phi v. तो दोनों को equate किया जा सकता है. So 1 को 2 से equate कर दो. Implies in the equation number 1 I had y square by z square del z by del x. In the equation 2 I have y square by x into 1 by z minus y by z square del z by del y del z by del y. Okay, so z square को LCM ले लेते हैं. Take del square z square x as LCM. सो यहाँ पर आ जाएगा एक्स वाई स्क्वायर डेल जेड बाई डेल एक्स इज इक्वल टू वाई स्क्वायर इंटू जेड स्क्वायर बाई जेड. तो ये आ जाएगा वाई स्क्वायर जेड माइनस एक्स वाई डेल जेड बाई डेल वाई del z by del y. Understood? So it implies x y square del z by del x plus x y del z by del y x y del z by del y is equal to z y square. So it implies x del z by del x plus x by y del z by del y and this is equal to z. ये हमारा आंसर आ गया. If you want to convert it into P and Q, then I can write xp plus x by yq is equal to z. This is your answer. ठीक है. So ये हमारा फाइनल आंसर है. xp plus x by yq xp plus yq रुको आई गेस वी मेड सम मिस्टेक. कहीं कुछ गड़बड़ करी है. सी u वॉज x बाई वाई है ना एंड v वॉज y बाई जेड. ठीक है. सो व्हेन आई डिफ्रेंशिएटेड विद रिस्पेक्ट टू x तो ये आएगा 1 बाई वाई. ठीक है, वो सही है. With respect to x, it will be y into minus 1 by z square del z by del x. So correct it is minus 5 by z square del z by del x. So phi u by y is equal to y by z square. Correct है. Equation 1 is correct. I guess we did some mistake in equation 2. Equation 2 को assess करते हैं. यहाँ पर this is phi y is equal to 0. u with respect to y will be minus x by y square. Correct. v with respect to y will be 1 by z. ठीक है. plus y into minus 1 by z square del z by del y. Correct. So it is 1 by z minus y by z square del z by del y, and ये भी माइनस साइन के साथ है. So I took it to the other side. X by y square is equal to 5y. 5e 1 by z minus y by z. This is correct. So then I found 5u by 5e. So I took it to the other side. Y square by x. 1 by z minus y by z square, ये भी सही है ना. तो उसके बाद मैंने 1 और 2 को इक्वेट किया. y स्क्वायर बाई जेड स्क्वायर डेल जेड बाई डेल एक्स इज इक्वल टू वाई स्क्वायर बाई एक्स. तो मिस्टेक कहाँ हुई है? In equation number 1, 5u by 5v y square by z square, ये भी सही है. मे बी द आंसर इज रॉन्ग बिकॉज मुझे कोई गलती नहीं दिख रही है इसमें. आई टुक जेड स्क्वायर एक्स एज एलसीएम. जेड स्क्वायर एक्स मैंने एलसीएम लिया, तो यहाँ पर क्या बचेगा? एक्स वाई स्क्वायर इज इक्वल टू, एंड हियर इट विल बी वाई स्क्वायर इंटू जेड स्क्वायर इंटू 1 बाई जेड. दैट मीन्स वाई स्क्वायर जेड. ठीक है. माइनस, ओहो, x इज़ ऑलरेडी देयर ना. x इज़ ऑलरेडी देयर विद जेड स्क्वायर. यहाँ मैंने मिस्टेक करी है. आई एम टेकिंग जेड स्क्वायर एक्स टू बी एलसीएम ना, तो यहाँ सिर्फ y आएगा. x वॉज ऑलरेडी देयर इन द डिनोमिनेटर ना. विद द सेकेंड टर्म x वॉज ऑलरेडी देयर इन द डिनोमिनेटर, सो सिर्फ y आएगा. तो यहाँ सिर्फ y आएगा, तो यहाँ सिर्फ y आएगा. एंड इस वजह से हाँ, नाउ इट्स कूल. सही है. यहाँ पर सिर्फ y आएगा, यहाँ पर भी सिर्फ y आएगा, यहाँ सिर्फ y आएगा, यहाँ पर भी सिर्फ y आएगा. सो दिस इज़ योर फाइनल आंसर. ऑल गुड. चलो, मूविंग ऑन टू द नेक्स्ट क्वेश्चन. Show that this is the partial differential equation obtained by eliminating f from this equation. Again same type का है solution. So आप सबसे पहले क्या करोगे? We are given that f of u comma v is equal to 0. u is equal to x square plus y square. v is equal to x square minus z square. है ना? So your first task is to differentiate with respect to x. Let's name it as equation 1. Differentiate 1 with respect to x. है ना? तो it implies fx is equal to 0. But fx कैसे लिखोगे? f is a function of u and v. Again you have to keep in mind f is a function of u and v are functions of x, y, z. ठीक है. So f will be differentiated with respect to u with respect to x, plus f with respect to v with respect to x is equal to 0. This is your fx. So it implies fu. What is ux? u with respect to x, it is just 2x. Plus f with respect to v. What is vx? v with respect to x, it will be 2x minus. Remember, z is a function of x. So 2z del z by del x is equal to 0. Because I am taking z to be the dependent variable here. So it implies I get fu into 2x. Again यहाँ से I'll get fu by fv is equal to 2z del z by del x minus 2x into fv. So यहाँ से आप क्या करोगे? रेशियो फाइंड कर लो fu by fv. Let's name it as equation number 2. Now you differentiate it again with respect to y. Differentiate 1 with respect to y. So I'll get fy is equal to 0. But fy को कैसे लिखोगे? fu with respect f with respect to u with respect to y plus f with respect to v with respect to y is equal to 0. So it implies fu. What is u with respect to y? It is 2y plus fv. Now v with respect to y. यहाँ पर तो y है ही नहीं, but z तो y का function है ना. So minus 2z del z by del y is equal to 0. So from here I get टू गोट कैंसल्ड आउट, एफ यू बाई एफ वी भी, यहाँ से भी एफ यू बाई एफ वी मिल जाएगा आपको. सो इफ़ यू लुक एट 2 and 3, तो लेफ्ट हैंड साइड दोनों में सेम है. सो 2 and 3, फ्रॉम 2 and 3 आई कैन इक्वेट एफ यू बाई एफ वी. You equate fu by fv, that is 2z del z by del x minus 2x. Two z del z by del x minus 2x by 2x z by y del z by del y. So it implies if you handle it, del z by del x minus x is equal to x z by y del z by del y, है ना. तो इसको कैसे करोगे? यू कैन हैंडल इट, आई मीन टू से यू कैन एक्सप्रेस इट, सिंप्लीफाई इट इफ यू कैन. तो आई कैन टेक z del z by del x minus x by y del z by del y. z del z by del x minus x by y del z by del y is equal to x. और we can say that z ये अपना p होता है minus x by y ये अपना q होता है is equal to x, and this is your final answer. In the question the answer is given as zyp minus xq is equal to xy. तो इसका मतलब उसने ना y को LCM लिया है. सो इफ़ यू टेक y एज LCM, सो yp minus xq is equal to xy. So this will be your final answer. ठीक है. Now I'm giving this problem as homework. इसको homework में रखो, इसको u रखो, इसको v रखो. You let me know the answer in the comment section. मतलब कर लेना, हो जाएगा. It's very simple. सेम वे में यू विल कंपेयर एफ यू बाई एफ वी, डिफ्रेंशिएट विद रिस्पेक्ट टू एक्स, फाइंड एफ यू बाई एफ वी, डिफ्रेंशिएट विद रिस्पेक्ट टू वाई, फाइंड एफ यू बाई एफ वी. दोनों को इक्वेट कर दो. सो दैट विल बी योर आंसर. ऑल राइट, देन आई विल सी यू टुमारो, मे बी एट 10:30, है ना. 10:30 पर विल मीट अगेन टुमारो. ओके, बाय एवरीवन, टेक केयर.